Motor control circuits tapped on the load side of a motor branch circuit require separate overcurrent protection. If a motor control circuit is connected to the load side of a motor branch circuit, it must have its own dedicated overcurrent protection. It's not unusual for manufacturers of motor-driven equipment to ship products without built-in overcurrent protection for the control circuits. Reducing the branch circuit breaker size will not solve the problem of an unprotected control circuit. Even with a smaller breaker, the control circuit will still be vulnerable if the motor malfunctions or draws excessive current. The National Electrical Code, specifically Article 430.71, requires separate overcurrent protection for motor control circuits. A control circuit without dedicated overcurrent protection violates this code. To address this violation, there are several possible solutions. Firstly, you can add a separate fuse or circuit breaker specifically for the control circuit. This provides independent protection against overcurrents in the control wiring. Secondly, a control transformer can isolate the control circuit and provide inherent overcurrent protection. This offers a robust solution. Thirdly, replacing the motor-driven equipment with a model that includes built-in overcurrent protection for the control circuit is another option. This ensures compliance from the start. Article 430.71 of the NEC outlines the requirements for control circuit overcurrent protection. It states that control circuits tapped from the load side of the motor branch circuit must be protected against overcurrents. This protection can be provided by fuses, circuit breakers, or other approved devices. The size of the overcurrent protection device must be appropriate for the conductor size of the control circuit wiring. The purpose of overcurrent protection is to protect the control circuit wiring from damage due to excessive current. Overcurrents can be caused by short circuits, ground faults, or overloads. If the control circuit wiring is not properly protected, it can overheat and potentially cause a fire. When selecting overcurrent protection for a motor control circuit, it's essential to consider the specific requirements of the equipment being controlled. Some equipment may require specific types of overcurrent protection, such as time delay fuses or instantaneous trip circuit breakers. It is also important to ensure that the overcurrent protection device is properly sized for the control circuit wiring. Using an undersized overcurrent protection device can result in nuisance tripping, while using an oversized device can leave the wiring unprotected. Control transformers can be used to isolate the control circuit from the power source and provide overcurrent protection. A control transformer steps down the voltage from the power source to a low voltage that is suitable for the control circuit. The transformer also provides isolation, which can help to protect the control circuit from electrical noise and surges. Control transformers typically have built-in overcurrent protection, such as fuses or circuit breakers. This protection helps to protect the control circuit wiring from damage due to overcurrents. When installing a control transformer, it is important to follow the manufacturer's instructions. The transformer should be properly grounded and protected from the environment. The wiring connection should be made securely and according to the electrical code. When adding a separate fuse or circuit breaker for the control circuit, it is important to select a device that is properly sized for the control circuit wiring. The size of the overcurrent protection device should be based on the ampacity of the control circuit conductors. The ampacity of a conductor is the maximum amount of current that it can safely carry. The ampacity of a conductor is determined by its size, material, and insulation type. The NEC provides tables that list the ampacities of various conductors. When selecting an overcurrent protection device, it is important to consider the type of load that the control circuit will be supplying. Some loads, such as motors, can draw a large amount of current when they start up. This inrush current can cause the overcurrent protection device to trip if it is not properly sized. To avoid nuisance tripping, it may be necessary to use a time delay fuse or a circuit breaker with a high instantaneous trip rating. When replacing motor-driven equipment with a model that includes built-in overcurrent protection for the control circuit, it is important to ensure that the new equipment meets all applicable safety standards. The new equipment should be listed by a qualified testing laboratory, such as Underwriters Laboratories or Intertek. The new equipment should also be installed according to the manufacturer's instructions and the electrical code. When working with electrical equipment, it is important to take all necessary safety precautions. Always disconnect the power before working on any electrical circuits. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not qualified to work on electrical equipment, consult a licensed electrician. Article 430 covers motors, motor circuits, and controllers. Article 430.71 specifically addresses the overcurrent protection of control circuits. The code mandates that motor control circuits tapped from the load side of a motor branch circuit must be protected. This protection is typically achieved using fuses or circuit breakers. The overcurrent device protects the control circuit conductors from overloads and short circuits. Without proper protection, a fault in the control circuit could damage the wiring or create a fire hazard. Manufacturers sometimes omit overcurrent protection on control circuits within motor-driven equipment. This is a cost-saving measure, but it places the responsibility for protection on the installer. Reducing the size of the motor branch circuit breaker is not an acceptable substitute for control circuit protection. The branch circuit breaker protects the motor and its wiring, not the control circuit. The control circuit conductors are often smaller gauge than the motor branch circuit conductors and require separate protection. A common solution is to install a small fuse block in the control circuit wiring near the point where it taps off the motor branch circuit. The fuse should be sized according to the ampacity of the control circuit conductors. Another option is to use a control transformer with built-in overcurrent protection. The transformer isolates the control circuit from the main power supply and provides a safe, reliable source of power. The transformer's overcurrent protection safeguards the control circuit wiring. In some cases, it may be necessary to replace the motor-driven equipment with a model that includes overcurrent protection for the control circuit. This is the most comprehensive solution, but it can also be the most expensive. When selecting a replacement motor-driven equipment, be sure to verify that it complies with all applicable safety standards. The National Electrical Code is a comprehensive set of standards for electrical installations. It is important to consult the NEC and any local electrical codes before installing or modifying any electrical equipment. Electrical work should be performed by qualified personnel who are familiar with the NEC and local codes. Proper overcurrent protection of motor control circuits is essential for electrical safety. It protects the wiring from damage and reduces the risk of fire. By following the NEC requirements and using appropriate overcurrent protection devices, you can ensure a safe and reliable electrical installation. Remember to always de-energize the circuit before working on electrical equipment. Use appropriate personal protective equipment. If you are not qualified to perform electrical work, consult a licensed electrician. The importance of providing overcurrent protection for motor control circuits cannot be overstated. It is a critical safety measure that protects against potential hazards. By understanding the NEC requirements and implementing appropriate protection strategies, you can ensure a safe and compliant electrical installation. Overcurrent protection devices are designed to interrupt the flow of current when it exceeds a predetermined level. This protects the wiring and equipment from damage caused by overloads and short circuits. Fuses are one type of overcurrent protection device. They consist of a thin strip of metal that melts and breaks the circuit when the current exceeds the fuse's rating. Circuit breakers are another type of overcurrent protection device. They use a mechanical mechanism to interrupt the circuit when the current exceeds the breaker's rating. Circuit breakers can be reset after they trip, while fuses must be replaced. The choice between fuses and circuit breakers depends on the specific application. Fuses are generally less expensive than circuit breakers, but they must be replaced after they trip. Circuit breakers are more expensive, but they can be reset and reused. The size of the overcurrent protection device must be carefully selected to match the ampacity of the circuit conductors. The ampacity of a conductor is the maximum amount of current that it can safely carry. The NEC provides tables that list the ampacities of various conductors. Using an undersized overcurrent protection device can result in nuisance tripping, while using an oversized device can leave the wiring unprotected. Control transformers are used to step down the voltage from the main power supply to a low voltage that is suitable for the control circuit. They also provide isolation between the main power supply and the control circuit, which can help to protect against electrical noise and surges. Control transformers often have built-in overcurrent protection, such as fuses or circuit breakers. This protection safeguards the control circuit wiring from overloads and short circuits. When installing a control transformer, it is important to follow the manufacturer's instructions. The transformer should be properly grounded and protected from the environment. The wiring connection should be made securely and according to the electrical code. Replacing motor-driven equipment with a model that includes overcurrent protection for the control circuit is the most comprehensive solution. This ensures that the equipment complies with all applicable safety standards and that the control circuit is properly protected. When selecting a replacement motor-driven equipment, be sure to verify that it is listed by a qualified testing laboratory such as Underwriters Laboratories or Intertech. The equipment should also be installed according to the manufacturer's instructions and the electrical code. In summary, providing separate overcurrent protection for motor control circuits tapped from the load side of a motor branch circuit is a crucial safety requirement. The NEC mandates this protection, and failure to comply can result in electrical hazards. Several solutions are available, including adding fuses or circuit breakers, using control transformers, or replacing the motor-driven equipment with a model that includes built-in overcurrent protection. By following the NEC requirements and implementing appropriate protection strategies, you can ensure a safe and compliant electrical installation. Always prioritize safety when working with electrical equipment and consult with qualified personnel if you have any questions or concerns. Remember that electrical codes and standards are subject to change, so it is important to stay up to date on the latest requirements. By doing so, you can help to prevent electrical accidents and ensure the safety of people and property.